Here we go. Let's do this. The first thing we got to do. Assume independence. Right small. Now, I'm going to do this a little differently than how I've been doing it on the slides. Right now on the slides, I've been kind of moving like vertically, like up and down. Oh my gosh, that was a poor time to stop writing. I'm going to get in so much trouble. Sorry about that for my subscribers. Okay. That was not intentional. No one's going to believe me, but that was not intentional. On the slides, I've been going, like vertically, like doing that. I'm going to go horizontally with my sentences. Okay? So I'm going to write small that way. All right, so who's got the sentence?
One child that may have Ricketts disease doesn't affect another child.
That's exactly right, Catherine. I'm going to just put it because it doesn't say, like it says deficient in vitamin D. It mentions this disease, Ricketts, but it doesn't say that like they have it or not. It just says that if they have a vitamin D deficiency, then we're worried about it. So I'm going to say one child being deficient in vitamin D will not affect another child. What's wrong?
That was a good laugh, sir.
You're welcome.
No one else noticed except.
That's true.
I'm just very
That's very
attentive.
true.
I was like, I was like, why are you laughing at me?
It's all about
I thought he was losing.
That's what I think most of
Okay. What do you guys think? Do you feel okay about this?
Yes.
Okay. Thomas is feeling very good about it. All right. So then let's go ahead and move to the next condition, which is the randomization condition. Remember, almost all of you are going to be taking this quiz tomorrow, and you have to have this stuff memorized. Does it say anything about random?
No, it does not.
It does. They were randomly selected from all parts of England. So
They have beef too.
do they? They have beef? They should just eat it.
Oh my gosh, he's such a bad guy.
Oh, man, I thought it was pretty good. Gosh. Let's do the next one, the 10% condition. Remember the math we do here? N times 10, which is 2,700 times 10, which is 27,000. Are there more than 27,000 children in England? Why? That's the second time that somebody said that, unfortunately. Like, why?
Imagine being born there.
Imagine being born there. I don't know. Okay.
Just wake up.
What's wrong with the UK?
It has beef with the Brits.
You got
Yeah, they go way back.
from the crib.
Okay.
Ever since we declared independence.
Nice. That was a good one. You hear that one? Catherine had a good one.
The one time.
Oh, was I supposed to be saying it? Sorry. There are more than 27,000 children in England, so our sample is not too large. That's what I have to check right now. Well, we're going to assume that it's not, right, Thomas? We're going to assume that it's large enough with the sample size assumption. Okay? So this one is pretty straightforward, as straightforward as it can get. That 2,700 children is a large enough sample.
Take off my rings.
Good call. I'm always ringless in my dresser. The scandal! Yeah, I took it off one day, and my wife never wore hers. And I double scandal. And I asked her, I was like, do you care if I don't wear it? Because and she was like, no. Okay. All right.
I think she told us something about that freshman year.
Did she?
No.
Okay, now or now?
All right, let's do our other condition. Success, failure. This is our last condition. All right, what's this one again?
It's like you multiply it by the big.
Times
N
P and
times Q.
P.
Okay, now sometimes, as you noticed on Monday, sometimes they'll give you the proportion and you'll have to do the math, and sometimes you won't. Sometimes they'll give you the number of successes and you just got to do the subtraction. So let's see in this case, did they tell me out of the 2,700 children how many are deficient in vitamin D? No, but they did tell me the proportion, right? And this is a sample proportion. So what symbol do I use for 0.2? Well, p hat, right? P hat. Okay. So I'm going to do 2,700 times 0.2 and 2,700 times 0.8. All right. What's 20% of 2,700?
Like something.
Well, let's do it. What's 10% of 2,700?
27.
270, and then double it. 540.
Good job, Mr. You're amazing.
Take that away from 2,700.
It's something. 21, 60. I'm so sorry.
Thomas, you didn't see.
Wait, if it,
I said it in my
it can be
head.
too small for one.
Hold on.
Other.
I think we have a legitimate question here.
For sample size assumption, what number is too small? Is it below?
Oh, what are we looking for these numbers?
If they're over 10.
10 or higher. In this case, way over 10. So I write this, Eduardo. Both numbers are over 10. So 2,700 is large enough.
So the last two are both about being large.
No, so I always think of it like this. Listen, guys, this is important. Eduardo's trying to sort this in his brain. It might help your brain too. All right, it's okay. The 10% condition and the randomization condition are related to independence.
Okay.
So once we decide with 10% that our sample size is not too large, right, because that would be an issue with independence, then we check to make sure that it is large enough, which is what these two are for, the assumption and the condition. All right, so it's like not too large, all right, but it's large enough. Okay. All right, we ready for the statement?
Yes.
If you've gotten to a place where you're near this letter B, just go ahead and cross out the letter B. We'll answer it verbally at the end when we're done. And this will not be on the quiz tomorrow. This interpret question will not be on the quiz tomorrow. It will be on the AP exam though. Okay. So let's write down the conditions have been satisfied. So I will use the normal model to run a one proportion Z interval. All right, we're halfway there.
Then the first question, remember these like little confirmation statements at the end.
Totally. That's why I've been doing it for 11 years.
He's so smart.
No, I've just been doing it for a long time.
That's true. It is smart. It's not intelligent. You've done, you know.
What?
Shame on you.
That's an assumption, Thomas.
I
You
am
don't have the
so-
conditions for that.
I will just walk out now.
Are you recording?
Oh yeah, we're still recording. That was Eduardo and Thomas.
It's gonna be like a time capsule.
Yes. What if I use this video 30 years from now?
Oh my god,
Can you imagine? Well, that assumes I'm still alive in 30 years. Okay. Because you never know, Jonathan. You never know.
what if he went to the top now?
That's right. I vowed that day when I got down, I said, I'm never climbing a mountain ever again. No, because I don't want to die. Okay. As I was walking down, there was like an 8-year-old walking up, and I was like, yeah, right? No, they're alive. I'm just, I'm seriously. Right?
There was never a guy.
All right, so sample size 2,700. Our number of successes, they did not give us this. All right, we actually did calculate it though in one of our conditions. No, that's going to be our failure rate. So that's actually weird to say because our failure in this case are kids with regular or normal levels of vitamin D. All right, that's a failure. All right, let's do p hat. This they did give us. What is our sample proportion? Very good, Diana. 20%, 0.2. So if you hadn't already done this yet, you would multiply your sample size by your success rate to get our number of successes. So it's 540. Yes, and this is where we're going and saying, even though it is a success, we know that's not really a success in life, having a vitamin D deficiency.
Do you have to write that down?
No, definitely not. All right, but some kids just get like mad at me that I'm saying that. I'm like, I'm not saying that. Okay, ready for the formula?
Yeah.
All right, hopefully you have it memorized by now. So it's p hat plus or minus z star. Oh, here we go. Times. What's that stand for, Estrella? I don't know. Standard error. Good, Diana. Of p hat. I'll show you when we're finished what formulas you're going to get, and then I'll show you what formulas you wish you got. All right? So I'm sorry in advance. All right, do you remember the formula for the standard error of p hat?
And
Square root.
yeah, and times.
Oh, look, Maria's here. Yes.
Q hat
What up?
what up?
She's like, I'm done. Okay. Now, I'm going to show you the work that I expect to see tomorrow on the quiz. All right, so this is going to be less work than I showed on Monday because I will be using the calculator. All right, we'll be using the calculator to find some of these numbers. Okay? We know p hat is 0.2. Plus or minus z star. Now, go real quick back to the top. Where is it? Oh, right here. Right here, Thomas. 98% confidence level. Is that one that I have memorized?
No.
No. So right now, I'm going to like, ooh, TBD on that Z star.
Sorry.
Times the square root. This one I do know. 0.2 times 0.8 all over 2,700.
Are we going to use algebra?
Algebra?
So it would, the z-score would be,
I don't know yet.
no, if it was 60% confidence, what would the z-score be?
If it was 90% confidence, it would be 1.645. If it was 95% confidence, hint, hint, it would be 1.96. Those you should have memorized, those two.
98 and
This one is 98%. I do not have this memorized. So find, do you guys have like a little bit of area
Yes.
somewhere up? Somewhere up? Can you find a little area somewhere up? Yeah, or up and right, maybe? Okay, so here's what I do. Draw the normal model. It's going to be fine. Okay? What level of confidence? And yes, you're going to need your calculator here in a moment. What level of confidence are we doing for this problem?
98.
98%. So if there's 98% between here, and these are z-scores, okay? What is the area that's in each tail?
1.
1% is correct. I want to stop here and make sure everyone's okay with that. Right? You take the 98, subtract it from 100, you get 2. But you got to split it into the two tails. So 2 divided by 2 is 1%. Okay? So now if I know that there's 1% of the area below this z-score, I'm going to go to the calculator, and it's going to tell me the z-score that's associated with that value. That is my z-star.
Could you repeat that?
Yes.
Thank you.
I'm going to go to the calculator. I know I'm using a normal model. I've got the area to the left of some z-score. I can choose a function in the calculator for it to tell me the associated z-score. Ready?
Yes.
Let's turn it on. Don't worry, we're going to do this a million times.
So when do we have the test on this?
The test, not till February.
When do we have the test
Tomorrow.
What?
But you won't have to do this tomorrow on the quiz.
on this? Okay.
But these you will have to do this on the test
Okay. But
and on the AP exam.
How long, as long as we do it.
Not tomorrow. Yes, you're good. All right, ready?
Yes.
Second, VARS.
You lied to me.
Second VARS. I did lie to you?
No, Estrella lied to me.
Oh, okay. Second VARS. All right. We are trying to go,
We'll see, yeah.
we're trying to go backwards, right? I have the area. Right? 1%. Trying to go backwards. So this is, what do you write? Inverse norm, number 3. And if you're like, oh, I don't know what that is, we have used that before. Okay. Number 3. Now, I'm going to type in 1% as a decimal. What is the other one you could type in to get this z-score? Not 98. It's all 99%. Nice, Victor. It's all the area to the left. So I don't care which one you pick. Pick one right now. 0.01 or 0.99. Just pick one. I'll pick 0.01. Somebody out there pick 0.99. Thank you. I got negative 2.326. What'd you get? Excellent. She got positive 2.326. I got negative. So when I do this, I always get a negative. Do I care about the negative? No. Just drop it. Okay? So I'm going to write down for my z star 2.326. Now, once you have that down, go ahead and put your pencil down for a second. And let me show you. So we're all good on how I got 1.645. Okay? This one you're going to memorize, right? Yes, everybody good? All right, so if this is 90%, how much is in each tail? 5%, right? Again, you're not writing this. You're just watching. So second vars, number 3, 0.05. You're hoping to see 1.645. Okay, so that's why you're memorizing it. So what a lot of my students every year say, but Mr. Vandrick, if I know how to do that, do I need to memorize? No, because you technically can do it. Right? It's just 90% and 95% are used so much that it's worth your time to memorize. All right, back to the problem. Pick your pencil or pen back up. You okay? All right, now I'm going to find my interval. All right, and how do I do that? The calculator. Yes. So hit stat. Tests. Go over to tests. There's only one way to do right now. Letter A. 1 proportion Z interval. Letter A. It's the only one you've done so far. You will learn many, 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 many more, but for now, just one. What is our number of successes?
540.
540. Nice. Sample size. 2,700. And then be careful here. It's going to default to 0.95. So make sure you put in the right one. In this case, 98.
Y ahora
I'm glad we're capturing all this on the recording. Oh, oops. Hit too many enters. They'll understand someday.
I don't think you can even hear. Yeah, you can't hear.
You can't hear? Oh, okay.
You just gotta yell like me.
Like Thomas.
Okay.
Thomas featured.
All right. My lower number in the interval is 0.182. So 0.182. My upper number is 0.218. All right. We're almost done, Thomas. All right. I am.
98%.
What up, Catherine?
Oh.
98. You got it, Catherine. 98% confident. That. Whenever you need to pass the baton, let me know. That. Okay. The proportion of all English children that are vitamin D deficient is between 18.2% and 21.8%. Oh, we did it. Uh-oh. I'm very worried right now. Come back to life. No? Okay. There we go. Came back to life.